to the first intersection point, it has to be
to the rows. So Joyce, we're talking about number 11 over here. I have a graph with my calculator. The dilemma is my silly smartboard markers are too thin and my iPad is updating, so I can't use my super thin markers, so life is a party. But we were trying to do number 11. Area in common to the polar curves for sine of theta and r equals 2. So we have a circle and we have 4 leaf rows. And I started it at 3 leaf rows, I apologize. There we go. And I don't know my stuff in long story short, this intersection point right here and this intersection point right here. In between these intersection points, we do want to use a circle, but outside those intersection points, we do want to use the rows. So from 0 to that intersection, and from that intersection to this 0, we want to use the rows itself. So what have you guys figured out are these intersection points?
And the first one is 0.17453293.
which is maybe pi over.
Pi over 6?
Maybe pi over.
Is it?
Wait, was it 1 point what?
0.1745.
1.17.
And B is, and then the second intersection point is 0.87266.
And that is when theta equals, right? So say it again, 0.17.
45.
Yeah, those aren't nice.
Keep going.
329.
And then the other intersection,
0.8726646.
keep going, 0.17.
6646.
And if you were to figure out how those relate to radians, obviously 0.174 is bigger than 0. What's pi over 2 end up equaling? 1.5.
1.5707.
Okay. When does the flower or the leaf rows hit theta? Is it pi over 2? It shouldn't be. That's what the one. When's the next 0? Because you guys are in function mode right now, right? No.
I was.
It hits at 1.0471,
1.04.
which would be pi over 3.
So then, so from 0 to A, we're going to use 4 sine 3 theta.
Question?
D theta, so we have to plug it into our formula, which is
1/2.
Can we just multiply it by 2 so that
let me finish writing my integral. So it's 1/2 what? R squared, right?
Yeah.
Oh, happy day.
Oh, it's pretty great.
Figure out what to be thankful for. Okay, so 1/2 R squared. Okay, and this just gets the first part to the first intersection, and we need to go ahead and add from A to B.
And then from B to pi over 3.
Do you double check that?
Will someone else double check? Just to make sure.
I'm gonna go ahead and go into function mode real fast.
yeah.
Oh, we probably could have solved for it, right? Just like 0 divided by 4, sine 0 at 0 and pi, then 2 pi divided by 3, yeah. So 0 to pi over 3. That would have been a good solving by hand, yeah. Well, technically, we could have solved what Georgie was saying, setting the 2 equal to each other. You would have divided by 4, you would have gotten 1/2. Sine is 1/2 that. Pi over 6.
Oh yeah, pi over 18 is
Yeah.
the first one.
Because pi over 6 divided by 3 pi over 18. So I guess we could have done that instead of the a's and b's. But the function mode definitely works, right, guys? To find the intersections of the two and to find the zeros.
Who's gonna find the second?
Oh,
5 over 8.
yeah. Because you would have had sine of 3 theta equals 2 over 4 is 1 half. And sine equals 1 half at pi over 6, 5 pi over 6. You can have as many as you want. No. It's going to be negative in the other quadrant. So then you would divide both by 3. Does that make sense? So A should be pi over 18 and B should be 5 pi over 18. Does that make sense? Okay, have we plugged in, check?
Doing that now.
What's your idea about doubling, Jordan?
I was gonna say we could just double
The 0 to A?
yeah.
Possibly. I don't know. I get a little worried about that because I guess we could do zoom square to get a little better picture. This is probably a little bit distorted. I guess that could be the same area. Yeah, I guess that should be the same area. The way the distorted picture looks, I wouldn't have totally trusted it.
Times 3.
You did the 1 half.
Times 3.
It's E. It's just it
Right.
there's
Right, right, right.
So
So we just found the first petal, there are 3 petals total, and then times 3. Does that match up to what we should have?
yeah. But would it be better just to be safer than sorry, just do everything individually, not guess and say
As far, I mean, the times 3 is obvious because we have 3 petals. They're exactly correct. So the 3 petals are fine. I don't know. I would say it's probably safest to set up the first petal completely just to make sure you don't make any mistakes.
yeah.
But I see what you mean by the symmetry, and you're right, that the area from 0 to A should have been the same from B to pi over 3. Does this one make sense okay?
Yeah. I think it's every time.
No, that's a gnarly one. But I think we have area common. Don't we have addition in our forever endeavor card? Between is subtraction. I think area in common we have addition, if I remember right now in endeavor card. Okay. Do you guys want to look at any other ones?
The FRQ 1.
Put this one? Calculator aloud?
Yeah, I'm not sure I did it right, and I didn't get D.
Okay, B didn't make sense. Okay, were your angles 0 pi over 2 pi, 3 pi over 2?
Horizontal tangents, we want to find dy dx, right?
dy dtheta. When dy dtheta equals 0.
Oh, I was saying dy dx, but then we say that set the numerator equal to 0, which would be dy dθ. Yeah, that's true. We could have made that jump.
Or it's gotten up there, so you wouldn't calculate.
And how do you know exactly what happens?
I wonder if these are the right ones that they might be.
There was a lot that I got on the interval 0 to 5. I got like 5 angles. 103, 1.57, 1.5, 1.7, 6.3. Because I got like a bunch of angles and I'm like not trying to show this, right? And the answer E was not mine.
It should be all the zeros of sine and cosine, right? Except, what do we have to be careful of? Why maybe should we have not just looked at y prime?
Possible
Make sure it's not undefined. Perhaps.
Wait, no, that would only be the bottom. Wait, oh yeah.
Shouldn't there be a sine minus 3 sine squared?
should be a full cosine of, so it'd be 1 minus 6. Prove sine is cosine, that'd be negative 6 sine cosine, pull out a cosine, negative 6 sine.
Oh, that's it.
Okay, who's doing pictures for the group chat? Alright, here we go. So the first one is number 11. Good, that's E. Tell me when to go. Oh, struggle. Hold on. There you go. This is the last one, I think, right?
It was just 2. It was just the odds we had to do.
Okay. So the other one's even. Yeah, and that's just the extra page. Okay. So then checking out that one FRQ, they did what we did as far as dy dx. They did the top and the bottom. But I don't see a shared cosine in the bottom, so all those are okay. And I don't see a sine 1 minus sine of 6. Sorry, 1 minus 6 sine of theta. So no shared common factors, so we don't need to worry about that. So yeah, it truly was just y prime equal to 0. Which cosine equals 0, pi over 2 and 3 pi over 2, and then sine equals 1/6, hence the calculator problem. Go ahead and solve in the calculator. Calculatrice, calculator. But B was the next one you guys were asking about, right?
Did they just list them out? Oh, 2. Why did they only list 2, not a bunch?
It says quadrant 1.
Oh.
Write the equation of the line that passes through the origin and passes through. So if you're looking at each of your angles,
A line in part.
2.9 would be in the second quadrant. Pi over 2 and 3 pi over 2 would both be outside the first quadrant. Yeah, so just A. So A alone. So you can find x using r cosine theta, y using r sine theta.
But it doesn't ask for one. It just says find angles when at which the curve is more long tangents.
For B?
For A.
Yeah, so A they found, struggle, I keep finding the wrong thing.
On 4 different points.
In one rotation or one revolution. They should have said for 0 to 2 pi. So if you want to add that in the question, it's for 0 to 2 pi. Because you could technically go on forever. That's not.
I did too. Actually, I always do 0 to 7 because for some reason when I put 2 pi in, it says, oh,
Oh, it rounds down maybe? That makes sense. So in letter B, it was just because quadrant 1, so we're just using the point from quadrant 1. Letter C, you just needed to figure out your bounds, right? And it was only one curve, so no intersections, no shared, no common. So then how do we find the small loops of the polar curve?
you find the balance of the small little median.
How?
You look at the graph and say, okay, hit 0, goes loop and 0 again.
I know, but how do you know where the 0 is? Because in polar mode you can't do zeros.
Just do,
You can't.
a chart.
I can't just guess and check.
Or no, sorry, not-
Guess and check is dangerous if it's a calculator FRQ. Right? So couldn't we just graph the 1 minus 3 sine theta, and couldn't we put theta is our bounds? Couldn't we make our window just 0 to 2 pi? Oh, look. Oh, that's my theta min, theta max. Pause, function mode. Granted, some of you guys have been using your calculators to find intersections, but others haven't. So I'm going to go zoom, standard accept. I want to go from 0 to 2 pi. And I'm just trying to find the zeros. So I have my 2 zeros seemingly at second trace. Now, are they sometimes going to be nice radians like we saw with pi over 18 a second ago? Yeah, it could be. Or are they always? Not necessarily. Holy cow, it's taking forever. Come on. There we go.
Is it wrong to put decimals if there is a radian version of it? Like,
No.
even for pi.
If they say calculator aloud, just make sure you keep all the decimals.
So like even for pi, we could have written 3.1415.
Yeah. Yeah, that would have been appropriate. Especially if it's a calculator problem. If it's a non-calculator, I mean, there should be no need for decimals. But.
Yeah.
So we have 0.339. Well, I can just go check the answer key to show. And we can find the other 0 to be. Now, when we go back and look, hey, look, decimals. Now, technically, did you have to do on this one the pi minus? No, you didn't have to do the pi minus. There's finding the second quadrant equivalent, but you could have just as easily found the second 0 and just put that decimal instead. Now, they went ahead and used arc sign, but once again, you don't have to show that trig. You can literally just use your calculator to calculate a problem, jump to those decimals, and then 1/2 r squared.
They just put 1 minus 3 sine theta into the function, and they found the 0.
They didn't plug in 1/3. They took arc sine, sine inverse.
Oh.
They solved
Um,
for the first one, and then they said, hey, arc sine, first quadrant, there's going to be a similar angle in the second quadrant, just do pi minus. They used pre-cal. Not the AP, but these people that made this answer key. But this is a calculator problem, so I'm saying, hey, just find those two intersections like we just did, stoem as A, stoem as B. Use A and B as your bounds, right? We have a couple minutes. Anything else you want to look at? Okay. On your guys' shared drive, let me close the calculator. Algebra 1's coming in, it's going to take a test, yada, yada, yada. You guys do have your coding/writing. You have your multiple choice from your exam, and technically your FRQs, so we already went over them. So it's more just trying to answer for yourselves as far as what things you could have done to get those FRQs better. I think we've already worked on FRQs. So mostly it's going through your multiple choice. But I want the day that you come back, that Monday. We're going to go over any more questions on the polar and get it turned in / project. I don't really quite you guys. Then Monday and Tuesday, I'm foreseeing doing or going over any multiple choice from your mock exam that you have questions on and weren't able to correct. Yeah. And then we're turning in quoting. Look at AB's board. We're turning in quoting on Tuesday just to give you guys an extra day of grace for multiple people are traveling, et cetera, et cetera. Final corrections I have due Wednesday. That way, Monday and Tuesday to work out the kinks of any extra multiple choice you haven't been able to get done. And then I'm in your shared folder right now. I've added a new folder. Actually, just copied it from last year. AP exam review. There are like the tips and tricks and all that, but I have practice AP exams. I have a 2008 practice exam, and I also have a 2012 practice exams with answers at the end, so that you can check your multiple choice and your FRQs. They are not required; they are bonus. Technically, these other ones are good as well, the Peterson and the Princeton and the Barron's, but start with the College Board. You don't have to print out the entire practice exam in order to be able to do it. You can save it as a PDF on your phone, not have to use data by continually accessing my shared drive and work it out on paper. But to get the plus 5% in your test quiz category, that's where the bonus practice exams go. You have to attempt the whole thing, grade the whole thing, but you don't have to correct the whole thing. After we get back, we've gone through the 3 BC specifically in the foundation reviews. My goal is to print out a more recent practice exam, but sadly there's only literally the one that you took on Saturday that's in the new format. That's all we have. That's all we've given anyone. So it'll be another, but if you guys know your BC, you'll be fine on the new exam. It's just the questions are different and they might ask a little bit more conceptual every now and then. So then I'll print off another practice exam, and what I'm foreseeing is that's just playing with the AP practice exam because some of you are tired of the non-AP questions, but they did have us dig into the concepts, and a lot of them are AP-ish. But you're right, we'll go ahead and transition to full AP after that. Sound good? Cool. If you guys need tutoring hours, there are plenty of AP kids that are going to be discouraged today because less than half pass, as you guys kind of be able to tell. But what I'm trying to encourage them is that test we took earlier this year, maybe, I don't know, I think you guys will find a lot of your mistakes that we did. But they took it earlier than we ever had before, and they were one of my not trouble classes. They've struggled more than any other year. So it makes sense that that's where they were, but I'm trying to encourage them that doesn't necessarily mean where they are after 2 weeks of review or where they're going to be. So just so you know, any AP kids, just kind of lift them up a little bit and be like, hey, we can do this, get some rest over spring break. And that's my prayer for you guys too. You guys kind of can recuperate over spring break in some way, shape, or form. Spiritually, mentally, emotionally, because we want to finish the year out. But it's okay to admit that we need a little bit of a break. So praise the Lord, it's fine. I think those are all my logistics. That sound good?
What's the extra credit countdown?
How many practices do you do? No. I think I have a 2003 writing exam, but I think that's the one we did over Christmas. Does that sound right?
We did one over Christmas. I thought that was like Lagrange or
Yeah.
CPC.
The ones that we haven't seen yet. So I don't have the 2003 one up. I could probably find another one and put up, but I'm guessing there's more than enough because most of you went to more than 2 bonus exams. So please, 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 if you decide to do them, now start with college. Besides that, Georgie and I are headed to Baja on spring break, so we're going to be praying about that. The rest of you guys doing anything in particular you need to pray for traveling?
I'm gonna date us on Monday.
Okay. It's exciting. Go check out life.
Yeah. Are you officially going there? Or is this like you're still?
I'm still deciding because final lesson is still 5, so I'm deciding between.
Masters, I think, is still ongoing.
What?
Masters.
Joyce. She told me she puts us on like a faster speed now so she can get through it faster.
Yeah, I would too. Happy spring break, Joyce. I'll go ahead and stop the video so you don't have to keep on listening to random quickies. But I warned her the last couple of days. I'm like,